Okay, this one is 2018 AP Calculus A/B test. I'm gonna write down 2018 AP test, okay? So we did 2017, 2018, 2019, okay? Yeah, this one is recently released right out the questions. Okay, the file very blurry. All right, it's not clear. Okay, we just guess. It's okay. Okay, the first one is f is the function given by f of x. I'm gonna write down. Okay, that's clean. 4 over x. I think second one is 5x and minus 1. This is given. This is questions. F prime 2. Okay. So F prime 2 derivative. Okay. So if we have a graph over here, at x equal 2 over here, the derivative is the slope of this line tangent. Okay, that is f prime. Okay, at x equal 2. If we need y, you can find the y. If we don't need y, just use the x coordinate. But this one, we use the x coordinate only, okay? Now f of x, prime x, take derivative.
Yeah.
What is that? Negative 4.
You can do negative x.
It's okay. 4 times x to negative 1.
Negative 4. Oh, yeah. But then
negative 4 x to negative 2 is 1 over x squared, right?
Yeah.
So 5x derivative is 5. That's it, okay? After that,
then you can plug in a 2.
That's right, plug in 2 in the x, okay?
Then you get 4. So A.
Oh yeah, okay, that's give me. Yep, 4 is dense, okay?
Yeah.
Slope of this line of tangent equals to 4. Okay, very good. Okay, now let's do number 2. This is 6e to the 3x dx. Antiderivative, okay? Okay. So we can find the antiderivative. How can you find the antiderivative? E to the 3x, you can think about this one. E to the 3x, when you take a derivative, that is a 3e to the 3x, right?
Yeah.
Now we're gonna go back this one, from back over here. Divided by 3 again, right? Okay, so e to the x, now going to into antiderivative, it's gonna be looked like this way. E to the 3x, but divided by 3, right? Okay? When you take a derivative, you multiply by 3, but when you have, right, antiderivative divided by 3, okay, reverse way. Is okay? All right, after that, we need a constant, okay?
Yeah.
So how can you simplify this one? This is 1, 2 times e to the 3x and plus c, okay? Yeah. So 2 times e to the 3x plus c is a. That's the answer.
Okay. Yeah.
Y equal f of x. This is the graph of y equal f of x. So what is the limit? X close to 1 f of x. Okay. Already 1 means we include both. This means when x go to close to 1 from right hand side, x close to 1 from left hand side, that's going to have a 1 number. That is the limit value, okay? If you have a different number, that is not limit value, okay? In this case, 1 number limit, 2 numbers, we said limit doesn't exist, DNE. It's okay?
Yeah.
From graph, approach to the 1, what is the limit value? 1, right? It's okay? They close to 1 there. Okay, I'm going to remember. Limit x close to 1 from right hand side, f of x equals what? 1. It's okay? That is one side limit. The second one is move to the left. Limit x close to 1 from left hand side. Follow this graph. Where is the value? 3, right?
But there's a discontinuity.
Yeah, there's a discontinuity, but limit value also different, right? From right hand side, one limit is 1. From left hand side, limit is 3, right?
The limit doesn't exist. So
Yeah. We have to say DNE. It's okay?
Yeah.
All right, the number 4, I think that is f prime x.
Yeah, so we have to take an integral.
Yeah, okay. Plus 2x, right? And from here, I'm going to take f2 is 3. What is f of 1, right? Yeah.
Yeah.
This is what? Fundamental theorem of calculus, right?
Yeah.
F of b equals what? F of a plus a to b, change of their slope, right?
Yes.
That is a fundamental theorem of calculus. Or sometimes f of b minus f of a. Okay, the difference of these two numbers is what? Sum of each derivative, right? Slope integral. Same things. So we have f of 2, f of 1 there. Okay? F of 2 is given, that is 3. So f of 2 equals what is that? We start from right, left. F of 1, we start from here. We're going to add what? 1 to 2 or change in what? Derivative. Okay? That's fundamental theorem of calculus. This number is 3. Now we're going to find f of 1. But we take this one, 1 and 2. F prime is given over here. 3x squared and plus 2x and dx. Now let's find this one first. Antiderivative of this one, plus 1 is x cubed divided by 3, but we still have a 3, that is x cubed, right? Second one is x squared, okay? This is the antiderivative of this one, 1 and 2, take integral. How much? 2 cubed is 8, 2 squared is 4. After that, we subtract the 1 there. 1 plus 1 is 2. 12 minus 2 is what? 10. It's okay? So this number is 10. So f of 1 is how much? Minus 10 both sides. Because we know that 3 equals f of 1 plus 10. So minus 10 and minus 10. F of 1 equals how much? Negative 7, right?
Yeah.
This is a fundamental theorem of calculus, FTC, okay? All right, number 5. People per minute, that's the rate, okay? Every minute, okay? People, what is that? Evacuation drill, okay. Evacuation drill, okay, that is the rate, okay, yeah. Leave the building at the rate of RT, okay, this is RT. RT is the rate, okay, over here. People per minute, okay. In 0 seconds, 100 people evacuate. At 5 seconds, another 100 people evacuate. 10 people at 10, 75 people evacuation, okay? That's the minute. You have selected the number up there. 0, this is 5, right? And 10, 15. The other is 100, 100, this is 55 and 55. Okay, using right Riemann sum of these subintervals, they are from the table, okay? What is the approximation, right? I think that is what is the approximation of number of people who leave the building during first 15 minutes. Take integral, right? So we're going to take integral, but there's no equations. That's why we have to use Riemann sum approximations. Okay? But they're asking you use what? Write Riemann sum. Okay, now let's make the graph over here. When t equals 0, t equals 0, there is 100 there. Okay, that is RT graph, okay? At 5, that equal in subinterval, right? 5, there is 100. And 10, 75. And 15, 55. The right hand side, this is rectangle, first rectangle. This is second rectangle, third rectangle. Oh, it's 3 rectangle, right? 1, 2, 3 sub intervals there. Okay? Sum of this one. So actually this one is exactly equals to what? From 0 to 15 RT with the time t, right? That is what sum of all people who evacuate first 15 minutes. Is it okay? Yeah, this one is this one. But this one using Riemann sum, we use this Riemann right hand Riemann sum, okay? Okay, now let's find over here. This is 5, this is 100. What is the area of this one? 5 times 100 is what? 500 people during first 5 seconds, 5 minutes. Altogether, 500 people there evacuate. It's okay? 5 to 10, every second, 75. 5 seconds, what? 5 times 75. 375, right? People evacuate. The last one is, this is also 5. Height is 55. 5 times 55 is 275. 275 people evacuate. The total number of evacuated people, approximately how much? 500, 375, and 275. These two equals 100, 650. Another 500. Total is 1150. Is okay?
Yeah.
Total number of this one is approximately 1150. Okay, next one. Y equals x squared dig e to the x minus 1 and then dy dx. Alright, take a derivative. Alright, we have two functions there, so a product rule. Okay, first derivative is 2x times second one e to the x minus 1. Don't touch first one. Take a derivative of second one. E to the x negative 1 derivative is still e to the x. That's it. But we have many like terms, 2x e to the x. 2x e to the x minus 2x plus 2x e to the x. 2x e to the x. 2x e to the x. Let me see. We have answer there. Actually, this is a 4x e to the x minus 2x. But we don't have that, right? Let me check this one more time. X squared e to the x, right? Oh, yeah, I did it wrong, right? Oh my god, that's too bad. First one doesn't change. This is the first one, x squared, okay? Don't touch. Second one is derivative by e to the x. Okay, that is my policy. So this one is what, x squared e to the x. Okay, this is highest degree. I'm gonna write this is first. X squared e to the x. Second one is e to the x, and minus 2x. Okay, looks like choice C is the answer. Ah, okay, let's see. A little small, that is better. Okay, particle moves along the x-axis so that at any time t, x-axis. So that any time t is positive. Its acceleration is given by that is negative 4. Okay. Accelerate, I think negative, looks like negative, accelerate is negative 4 sine 2t. If the velocity of particle is t equals 0, that is initial condition t equals 0, velocity is 7.
Yeah.
Its position t equals 0, position is 0, okay? x0 equals 0. That is initial conditions. They already give this one, right? Using starting from acceleration, we're gonna find the velocity and position, okay? From the given IC, initial condition there. Let's try this one, velocity. Velocity is acceleration, antiderivative, negative 4 sine 2t. Antiderivative, maybe check it out. Sine 2t is what, negative cosine, right? Okay. Cosine 2t, when you take a derivative, that is what? Negative sine 2t and times 2, isn't it? So, antiderivative of sine 2t is what is that? Negative 2, right? Yeah. It's okay? So this is exactly how much? Divided by negative 2, okay? This one divided by negative 2 is what? 2, it's okay? 2 cosine 2t. Are you okay with this?
Yeah.
That is the antiderivative. Okay? Or you can check it out. 2 cosine 2t derivative. Okay? Minus 2 sine 2t. After that, times 2 over here, right? So 2 times negative 2 is negative 4 sine 2t. That's okay? That's fine. This is antiderivative. 2 cosine 2t. And the plus c. Now using the initial conditions, when t equals 0, velocity is 7. This velocity equals 7, okay? When t equals 0. So v0 equals to 7. 7 equals v0 there. 2 times cosine 0 plus c. Cosine 0 is 1, okay? 2 times 1 is 2. So 7 equals 2 plus c. From here, you can say c equals to 5, okay? So now velocity. This is the velocity given by this way. Velocity is now 2 cosine 2t and c is 5. That is the velocity. Now we need to go one more times to go up position. Position is antiderivative velocity. So cosine t antiderivative, we can see that the derivative of sine is a cosine, right? It's going to be sine, okay? But you're gonna divide by 2 again. So sine 2t. Divided by 2, we got the 2 there, that is 1, right? Yeah. You can check it out. Sine 2t, derivative how much? Sine 2t is a cosine 2t, right? Sine is a cosine. And times 2, right? Chain rule is a 2 cosine 2t. This is it, right? So, antiderivative of 2 cosine 2t equals sine 2t. It's okay. And we have a 5 over here, that is 5t, okay? And plus is. Now initial condition when t equals 0, y equals 0, x equals 0 over here. 0 is 0, okay? Put this number 0 in there. Sine 0. This is 0. This is sine 0 equals to what? 0. C equals to what? 0, okay? C is also 0. So this number is 0. So xt is actually equal to sine 2x plus 5t, okay? Sine 2t plus 5 is not x. That's correct. Okay, we remember this same as these questions every test. Is okay? Using acceleration, you're gonna find velocity and find position. Okay? That is number 7. Yeah, this is number 8. We have a graph of f prime, second prime, not first prime. The first prime, second prime is derivative given by shown above, which of the following could be graph of f original graph. Using only what? Second derivative, right? This is 1, negative 1. This is 1 there. This is a little lower over here. The graph looks like this. This is a second derivative graph. That is positive means what? Up to here, that is concave up, right?
Yeah.
To here. I'm gonna make line over here. Up to here, concave up. Here is minus. All the way down is what? Concave down.
Yeah.
And over here, concave up over here, right? Concave up, concave down. This is my inflection point at this point. Are you okay with this? They change right there. Concavity, right? Okay, now let's do concave up first one. This is not concave up. This is concave down. This is concave down. This is concave up. B or C there.
Yeah.
At this point, in the middle of here, they change right. Their concavity, right?
Yeah.
Okay. Concave down. Which was concave down? Up to here. So over here, concave up there, right? The graph is concave up. After that, concave down is what?
Same thing. It's going down here.
Okay. All the way this one, okay, from this point, this one concave down, right?
Yeah.
So from here to here, concave down, okay?
Yeah.
After this point, concave up again, right? This is concave up. It's okay? Positive. Concave up. From 1 to 1, that is concave down, okay? And the concave up, all right? Choice is that. So are you okay with this?
Yeah.
The last one over here, concave up there, right? This is concave down, okay? You can cross out from the last part, right? Are you okay with this? With using elimination, okay?
Yeah.
AB is about first there is concave up, but this is concave down, concave down. Last one is also concave up, but this is a concave up. This is okay, but this is concave down out. Okay, so A, B, C, they are all out from first and last one. Okay.
Yeah. Makes sense.
All right, number 9. When x is 2e, limit. This is a little clear. Sorry. Limit h close to 0, ln x plus h minus ln x over h. Okay. What is this one? If f of x equals ln x, this is what f prime x, right?
Yeah.
The definition of f prime x. So what is f prime x from here? F prime x equals what is that? 1 over x. Are you okay with this?
Yes.
But we're gonna find what when x equals 2e, okay? This value is how much? F prime x is 2e. Okay,
Yeah.
plug this one 2e in the x. 1 over 2e is okay.
Yeah.
Choice A is the answer, okay?
Yeah.
All right, number 10, what that is the third derivative, not second derivative. It's okay? We take a derivative via 3 times, but first derivative is already given, okay? All right. So second derivative. I'm going to write this is a y prime, okay? You can use this y prime. So y second prime, what is that? Y second prime, that is what? Y second prime, this equals what? D squared y over dx squared, is it? Second prime, right?
Yeah.
Okay. How much is this one? 4x cubed minus 6x squared and the plus 3, right? You know how to do this one. The third derivative. Third. Take what? 3 times 4 is 12x, 3 minus 1 is squared, and minus 12x. Constant is 0. So we're going to find, okay, third at x equals 2 there. Plug this number 2, put this number 2 in the x. 12 times 2 squared. 2 squared is 4. 12 times x is 2. So 12 times 4 is 48, and minus 24 equals 24, okay? That is the value of what? This third derivative at x equals 2.
Yeah.
Right. Now move on to the next one. We have piecewise functions. So we're going to find from negative 1 to 1 the area under this curve. From 0, right? Okay, I'm going to find out here. Less than 0, we follow the x squared. This is the graph of x squared, less than 0. Are you okay with this? Because what? This is the graph of this way, right? But we take right x is less than 0. Left hand side. We don't need the right hand side. The next one, when x equals 0, the value of y is negative 1 there. Actual value. This is a limit value 0, this is a negative 1 there. And the x equals positive, we followed what? X. X graph is this one. So we take integral from negative 1 to, from here, negative 1 to positive 1 over here. Under the curve is what? This area, right? This point is about no dimension. This is not the area. It doesn't have any area, okay? So now let's find this one. First one, from negative 1 to 0. Okay, we follow the x squared, dx. And the plus 0 to what? 1 over here, okay? But actually this one is what? B, take this, B is close to 0, right? Emily,
Yeah.
okay, you can use it this way, b close to 0. Because x cannot be 0, okay? And also another one. I'm going to take right k greater than 0. Okay, we start over here, k equals 0 to 1, and follow this graph is y equals x dx. Antiderivative of x squared is what? Plus 1 is x squared, x cubed divide the same number, right? X cubed over 3. We take what? Negative 1 to b. Okay? And the plus x squared over 2, right? Antiderivative, we take this one, k to 1. But still, we have a limit b close to 0, limit k close to 0. Because that's still 0 there, right? This is what it is. Limit b close to 0, b cubed over 3 minus negative 1 there, okay? Minus negative 1, how much? Negative 1 over 3, isn't it?
Yeah.
But still, this is 0, right? That's why you can use, right, just over here. Negative 1, 0, x squared plus d squared. Because this is what? Part. Okay? Part doesn't affect the area, okay? So you can use that's why x cubed over 3 and take integral from negative 1 to 0, okay? Put this number 0 there. 0 minus negative 1/3 will be positive 1/3. Same thing, okay? This is 0. Negative, positive 1/3, first one.
Yeah.
Second one over here, k equals 0, right? Just put this number 1 there. 1 over 2, isn't it? K squared over 2 is what? K equals 0, that is 0. So when you add these two, this area is 1/3, the other area is 1/2. But this is no dimensions. Okay, sum of these two numbers is what is that? 5 over 6, okay?
Yeah.
That's the area. Are you okay with this? Right?
Yeah.
Okay. Number 12. Given that 3x minus tangent y is 4, and what is dy over dx in terms of y? dy dx. We have a 3x tangent y. You better use your implicit differentiation, right? Implicit differentiation. Because we cannot express y in terms of x. That is a little difficult to express y, okay? That's why we use implicit differentiation, okay? Take a derivative first. 3x derivative is 3. Minus tangent y derivative how much? Secant square of y. But y is a function of x. We take y derivative with this y again. That is dy dx, okay? Or y prime. And derivative constant will be 0. Where is dy dx? This is dy dx.
Yeah.
So 3 equals secant square of y and dy dx. So to find dy dx, you can divide 3 by secant square of y. That is dy dx. Okay? Where is this one? 1 over secant square of y. 1 over secant square of y is what is it? Cosine y, then it's reciprocal, right?
Yeah.
Is okay? Square is what? Cosine square of y. That equals what? 3 cosine square of y, okay? So where is this? 3 cosine squared of y. Choice B is the answer, okay?
Yeah.
That's number 12. Number 13. For the time t is greater than or equals to 1, the position of particle moves along the x-axis is given by position. They use the letter p. Square root t and minus 2. That is position, right? Position is what? Where is the particle? That's it. When t equals 0, where is the particle? When you move this one, it's a 0 over here, right? When t equals 0, particle is a negative 2 over here. Particle, we start from here. when t is 4, what happens? When t is 4, what happens? Put this number 4 there. 4 square root 4 is what? 2 minus 2 is 0, right?
Yeah.
Over here, particle move to the right. At time t equals 4, it is now on origin. Okay? That's the positions. All right, instantaneous velocity of particle, right? That is the velocity. Okay, equal to the average velocity of particle over 1 to 16. Instantaneous velocity at time t in interval, right?
Yeah.
Let me see. At time t interval, this one is instantaneous velocity. Okay, this is instantaneous velocity, the bt, right? This one is actually equal to average velocity. Okay, average velocity of particle over this one. What is the average velocity? What is the average velocity? Average value of velocity, same thing. It's okay?
Yeah.
All right. Average value of velocity, what is it? Between 1 to 16, b minus a is 16 minus 1. We take all integral under this velocity. What is this? Is a position, right? Okay, velocity is a vt dt. From where? 1 to 16. Are you okay with this? Yeah, that is equals. Okay, this velocity is equal every value of velocity. Now take out this one. 1 over 16 minus 1 is 15. But the velocity is what its position, right? Antiderivative position over here, isn't it? It's okay? Yeah, you don't have to find, okay? It's already given the antiderivative velocity is positions. So that is the square root t minus 2, we take integral 1 to 16.
Yeah.
Okay? Now let's find over here. Okay, I'm going to find this. Square root 16 is 4, right? 4 minus 2 is still 2. And minus square root 1 there, 1 minus 2. How about this one? 1 over 15, inside is what? 2 minus 1 is 3, right?
Yeah.
So 3 over 15 is going to be equals to 1 over 5. So the question a little weird. At what time t? Oh, I'm sorry. What time t? It's okay over here, right? Okay. At what time t? That equal this much velocity. Okay.
Yeah.
Now we're gonna find, okay, instantaneous velocity is a derivative. We're gonna find any velocity over here. Okay. Okay. Same as this number for what time t. Okay, velocity p prime t is what velocity is. Okay. Velocity is this is t to the 1/2 minus 2. Velocity 1 over 2 move to the front. 1 over 2 t to the 1 minus 1 is minus 1 over 2, right? It's okay. And the constant is velocity is 0. So this one is actually equals to 1 over 2 rad t, okay? This instantaneous slope must be equal to this one for some time value of t, right? We let this one is equals. They are equals. 1 over 2 rad square root t equals 3. It's okay? So you can use a cross multiplication. Okay? That's fine. 6 rad t equals 1. Rad square root t equals 1 over 6 t equals how much? 1 over 36. 1 over 36. That is no answer. Let me see. Charge movement. Average velocity of a particle. Average velocity 1 to 16, right?
Yeah.
So average we can divide by the base 16 minus 1 divided by 15, and each antiderivative square root t minus 2 1 over 15. This is 4. 16 over here. 4 minus 2, that is 2, and the minus 1 minus 2, that is negative 1. 1 plus negative plus 3, 3 over 5, 1 over 5, right? That's true. And the instantaneous velocity of particle p prime t, check one more time, pt equals t over 1 over 2 and minus 2. P prime t is the velocity. 1 over 2 t minus 1 is negative 1 over 2 and 0. 1 over 2, this one is 1 over square root t, square root t over here. 1 over 2 rad t. It must be equal average velocity. Equals to 1 over 5. How do I got 3 over there? Oh my god. 1 over 5, okay? Average value, okay? Not 3. Oh, this one. Calculate this one. I take right the long numbers. Okay, 1 over 5 is what? Average velocity, okay? So this one equals to 1 over 5. You have to solve this one, okay? Alright. Now cross multiplication is okay too. So 2 rad t equals 5. Square root t equals 5 over 2. T equals how much? Make a square, right? 25 over 2 squared is 4, right? At this time of t, 25 over 4, right? Instantaneous slope exactly equals to its average value of velocity, okay? So 25 over 4 is the answer. Are you okay with this?
Yeah.
Just give me a minute, okay? I'll check the next. Just give me a second, okay? I'm going to check my schedule. Just that is number 13, number 14 here. F is differentiable. Y equals sine x. I'm going to write it one more time over here. Clean, make clean. Sine f of x squared. Yeah, that's it. Okay. So we're going to find the dy dx at x equals 3, okay? Derivative. Now let's find the dy dx there. So we're going to find in terms of f of x or f prime x. From here, dy dx, take a derivative of sine first, cosine, right? After that, we're going to the f prime, isn't it? Times chain rule, f prime x squared. Going to the inside x squared derivative is how much? 2x. That is what? 3 chain rule, okay? Now put this number x is 3 in the x. So that is actually how much? I'm going to use, we use the f of x inside. What is that? dy dx. When x equals 3, cosine f of what? 3 squared is 9. And the f of prime 3 squared is 9. And time 2 times 3 is what? 6. Okay? So better use this one. Constant first, 6. The next is f second prime noun. After that, last one is some function, okay? That's this, okay? So where is this one? Choice, no, that's the choice D, right? Choice D, 6 f prime 9 cosine f9. Okay, choice D is the answer. This is chain rule questions. Okay. Any question on this number 14?
Yeah. No.
It's okay, right?
No.
The number 15, we have a graph of g prime. The first derivative of function g consists of semicircle and of radius 2 and 2 line segments. That's true. G of 0 is 1. What is g of 3? That is fundamentals of calculus. G of 3 equals how much? We start at g of 0. Add what? From 0 to 3, or change in derivative, right? G prime x dx, isn't it? Is it okay?
Yeah.
This is another what? Fundamental theorem of calculus, FTC. G of 0 is 1. G of 3 equals G of 0 is 1, 1 plus. And from 0 to 3, G prime x dx. We take integral G prime 0 to 3. G prime graph is already. We take integral area, right, from 0 to 3 up to here. This area, this area. That is equals to what? G prime x 0 to 3, G prime x dx. Is okay? What is there? This is one. Quarter of a circle. Radius is 2. Pi r squared.
Yeah.
4 pi. But this is a quarter. This is divided by 4 is by area is pi. Okay? The other area triangle. This is 1. Height is 2. This area is 1 times 2 and divided by 2 equals 1, right? So this area is 1, the other area is pi. So this value equals how much? Pi plus 1 there, okay? So 1 plus pi plus 1 equals how much? Pi plus 2, okay? That is the value of g over 3. Any question number 15?
No.
It is okay.
No.
All right, number 16. Let f be the function given by f of x, x cubed minus 6x squared minus 15x. I'm going to write this one more time. X cubed minus 6x squared and minus 15x. What is the maximum value of f on interval 0 to 6? Maximum value, absolute maximum, right? Just the maximum is what? Not relative maximum, okay? Just the what? Absolute maximum. Which one is the highest value?
Yeah.
Okay, anyway, we're going to find, okay, derivative, right? To find the graph of this one. 3x squared and minus 12x and minus 50. To make it equal 0, what happens? 3 is out, x squared minus 4x and minus 5 equals 0. So equals to 3, x minus 5, you can factor the x, plus 1 equals 0. So we have 2 points, x equals 5 and x equals negative 1. F prime x graph looks like this one. Y equals F prime x graph pass through the one, negative 1 and 5. Negative 1 and 5. We'll pass this one. From here, F prime is a positive. Between negative 1 and 5, negative, here is a positive. Increasing and decreasing. So up to here, increasing and decreasing all the way down, decreasing over here, okay? But over here, slope is 0, that is inflection point. Down, inflection point again, they're all decreasing, okay? Inflection point. Decreasing. This is what? Slope is negative, concave down, decreasing. After this point, concave up, decreasing. Okay? So at this point is what? Point of inflection. After that, increasing again, but concave up, increasing. But second derivative is positive. Graph looks like this. But this one is 0 to 6 there. Where is 0? Around over here, right? This is highest point. Maximum, again, local maximum, right? This is a little going down. I think that's fine. I think that's better adjust over here, okay? Grab. Here. That's better, right? Going down over 1 to 0 over here. We start from this point up to 6. Where is up to 6? This is 5, right? 5 is what minimum value, right? Absolute minimum, okay? All the way down. 6 we don't know over here. So we're gonna find the graph of this one from here. 0 to minimum down. 6 is a little higher, but we don't know. We compare these two numbers. Okay, maybe this is high over here, we don't know. All the other one is less than these two numbers, so forget about this one, okay? We just compare these two numbers. At x equals 0, how much? At x equals 0, 0, 0, 0 is 0, right?
Yeah.
At x equals 6, at x equals 6, how much? Put this number 6 there. 6 cubed is 216 minus this also at cube, right? 216 and minus 15 times 6 is negative 90, which is equals to what? Negative 90 there. This is negative 90, this is 0. Actually, the real graph looks like this way. From here all the way down, okay? All the way down, another down, right? A little over here, okay? This is negative 90. This is the actual graph, okay? This is 0. So negative 90, 0. Which one is highest point? 0 is the highest point. All other ones, they are less than 0, okay? So I'm going to show you the graph of this one. The graph of this one, y equals x cubed and minus 6x squared and minus 15x. We take this one on some restrict domain 0 to 6. This is the graph. Very low, right? It's okay?
Yeah.
From here, 0, highest point, all the way decreasing. Okay? concave down, this is still concave down decreasing, okay? But somewhere over here, concave up decreasing. It is minimum, now from here going a little up there. But this is negative 90 when x equals 6. So where is the highest point? Maximum is what? 0, right? That's the highest point. Are you okay with this?
Yeah.
All right. Looks like this, okay? Going all the way down, a little up, but still this is the highest point, okay? Maximum is 0, okay? Is the answer. Okay. So integral integral 1 over x squared plus 4x n plus 5 n dx. This one is hard. This is usually calculus BC questions. Because we know that arctangent x derivative, that equals what is that? 1 over 1 plus x squared, isn't it? Okay, if you got this form, you can go back over here, right? Arctangent x. But this is a little different, but take a look here. 1 over x squared plus 4x plus 5. I'm going to make it perfect squared form, okay? 1 over, this 2 is what? X plus 2 squared and the plus 1. Are you okay with this? Right? X2, this half of this is squared, that the 2 squared is 4. To make a 5, you need a 1, right? That's the equivalent. This is just look at this one. 1 over 1 plus x minus 2 squared dx. One more time. If we have this one, tangent x minus a over here, derivative. Still this is what it is. 1 plus x minus a squared or plus a squared. This is okay, a squared. Are you okay with this?
Yeah.
All right. So antiderivative of this one is how much? Arctangent x plus 2. Okay? Antiderivative this one is this one, but this is the arctangent x plus 2. But we need the plus c, okay? Choice A is the answer. You have to memorize this formula, okay, in case. I thought what belongs to these questions belong to a calculus BCA, but they use this one, okay? 1 over 1 plus x squared, okay? That is the arctangent, all right? The antiderivative is the arctangent, okay?
Yeah.
Second one is number 18. F is a function defined third order x. What is the approximation f10? Bounded by using the line tangent graph is at point is at 8 and 2, okay? So at point 8 and 2. If this is 8 and 2, using this line of tangent, we make approximate the value of what? F of 10, right? Because f of 10 is very close to 8, right? X is 10. We're gonna find that this is actual height, that is f over 10, by using this linear approximation up to here, right? Okay? Yeah, that is what linear approximation of this number 10, okay? We use the P, okay? P10. P is what? Equation of tangent, okay? Using this line. Not this one. This is the actual graph. This one is what? Approximation graph. Okay. Now let's find the equation of tangent. We got the point over here, a point 8 and 2. The only things we need is the slope, f prime x. This equals to x to the 1/3. Take a derivative. 1/3 move to the front, minus 1 is a negative 2/3. F prime x is 1/3, x to the what? 2/3, right?
Yeah.
That is a third, actually, maybe you can use what? Third root x squared over 1. You can use anything. But at x equal 8, okay? I'm going to this one. You don't have to. 1/3. X equal 8 is what? 8 is what? 2 cube. And 2/3 again. 3 is cancelled out. 2 square is 4. So 3 times 4 is 12. 1/12. That's the slope at this point. This slope is 1/12. And I got the 1 point. What is the equation of this line of tangent? Y minus y1 is 2. Slope is 1/2, x minus 8. So y value is what? 1/12 times x minus 8 and plus 2, right? That's the equations. You don't have to simplify, okay? Just find out, put this number, x is 10 there, okay? So f of 10, how much? P of 10, right? Yeah, this is an approximation. Degree 1 polynomial. P of 10 is how much? 1/12, 10 minus 8 is 2, and plus 2, right? This is 1/6 plus 2. So 1/6 plus 12/6 equals 13/6. It's okay? That is the approximation using the line of tangent. Okay, the better find the equation of line tangent, okay? Okay, let me check the next one. Okay, after this we'll finish today, okay?
Yeah. Okay.
All right, limit value. This number 0, okay? What is that? 0/0. We have this one. Are you okay with this? E to the 0 is 1. 1 minus 1 is 0, okay? So we can use L'Hopital's rule, okay? All right. Limit x equals 0. Take derivative, numerator, 8x. Take derivative denominator, 4 times e to the 4x and minus 4, right? And put this number 0 again. Numerator 0. Denominator also 0, right? When you check it out, it's still 0/0. One more times. 8x derivative is 8. E to the 4x derivative is about 4. Another 4 there, 16 e to the 4x. Now put the number 0 again, but numerator is not anymore 0, okay? That is 8. Denominator was 16 times e to the 0 is 1, right? 16. 1/2 is the limit value, okay? Okay, I'm gonna post this on YouTube and send out the link, okay?
Yeah.
All right, so you watch the video until you figure out completely all the questions under 19, okay?
Mm.
All right, I'm gonna